In this video, we're going to look at factoring quadratics that have a leading coefficient that is not 1, like this one here. The leading coefficient is 2. On this one, the leading coefficient is 1. We know there's an implied 1 in front of everything, but I'm going to take that off of there. These are way easier to factor than these are. However, I'm going to show you a way that is almost as easy as factoring these. And basically it's going to come down to taking something like this and making it look like this and then use the simple technique. But first you need to know how to do these. This needs to be second nature. I do have a video on factoring quadratics with a leading coefficient of 1 that you need to stop and see first. I've included the link in the description. But I am going to do this real quick. So if you have a quadratic with a leading coefficient of 1, this is the fastest, easiest technique I've ever seen. Just do this. Make a couple parentheses, put a variable in the front of each one, take that sign, bring it straight down. For this one, you are not going to bring this sign straight down. You are going to look at both of these and think of multiplication rules. A positive times a negative is a negative. And then we're looking for two numbers that multiply to 36, whatever this number is, and subtract to this. Whatever this sign is, that's what's going to happen with this number. If that was a plus, then they would have to add the 16. Okay, well, so what we're going to do is we have two criteria to fill. One is we need a pair of numbers that multiplies to 36. So let's figure out what all of those could possibly be. So just go right up the line and see, okay, is 36 divisible by 2? Yes, it is. Is it divisible by 3? Yes. 4? Yes. 5? No. 6? Yes. And this is all we're going to get. Okay, so is there something in here? Is there a pair of these that subtract to 16? And sure enough, there is. It's going to be these two. You always write the bigger number first, put the smaller number in the second parenthesis, and we are done. This is factored. If you FOIL this, you will get this back. But that's just a really fast view. That's all I'm going to say about it here, because we're going to move on to other techniques when it comes to this. So again, please watch the other video and then come back. Okay, so this is the first example of what I really wanted to get into in this video. You will notice the leading coefficient is not 1, it's 2. So what can we do about this? Well, the first thing you always check when you're ready to factor a quadratic is there something you can factor out of all three terms? Never forget to do that. Regardless of what the circumstances are, what kind of quadratic it is, no matter how complex, you always do that before you try any specific factoring technique. Do a general factoring technique first. Is there something that 2, 14, and 24 have in common, a common factor? Well, 2 divides by 2, 14 divides by 2, and 24 divides by 2. So we are going to immediately factor that out. And when you factor something out, you always take whatever the common factor is and you set it out here. Notice we don't have any variables that are common to all, so there's no way we could pull an x out. So the only thing they all have in common is a factor of 2. Okay, and then I want this times something here to equal this times something here to equal this, and this times something here to equal this. So 2 times what equals 2x squared? Well, let's just see, 2x squared divided by 2 is x squared. Okay, does this times this equal this? Yes, it does. Okay, well, what number is going to go here? Well, if we take negative 14x divided by 2, okay, negative divided by a positive is negative, 14 divided by 2 is 7, and we have the x. So negative 7x. Does this times this equal this? Yes, it does. Okay, and then 2 times what equals 24? Well, 24 divided by 2 is just 12. So this is the same as this. Okay. Always when you factor something out, reverse check it. See if when you distribute whatever you factored out, you get this back. Okay. Well, now the cool thing is, inside the parentheses, we have a quadratic that has a leading coefficient of 1. So now we're just going to take that over here to the side, and we're going to do the technique that we would normally use with a leading coefficient of 1. Bring that sign straight down. For this one, we have a negative times a positive. That's a negative. We want two numbers that multiply to 12 and add to 7. So we start making all of our possible factor pairs. Does 2 work? Yes. 2 times 6. Does 3 work? Yes. And I could say, well, does 4 work? But we've already done 4, which means we're not going to get any more. So this is the complete factor pair list for 12. Do we have something in here that adds to 7? Yes, we do. We have 3 and 4. So we write the bigger one first, smaller one second, always. Now here it wouldn't have made any difference because they're both negative, but just make it a habit to write the bigger one first, always. That way you'll always be right no matter what these signs are here. Okay, well now we're going to come back here. And remember, we just factored this part, but this 2 hasn't gone anywhere. It's still there. So our complete answer is going to be the 2 in front of this. And this is our factorization. If you FOIL all this out, you will get this back. In this example, we're going to get into the guts of what I really want to show you, because in this one, we are not going to be able to factor that 2 off like we did last time. So we're going to use a different technique this time. We don't have a common factor in all 3 terms, and we wish we had a quadratic that had a leading coefficient of 1, and so we're going to make that happen by doing this. Here's the technique that this video is all about. We're going to take the first number and multiply it by the last number. And here's what we're going to end up with. Okay, this is not the same thing as this, but that's okay because we're going to find a way to make it go back to what it should have been. What did I do? I took the first number and I multiplied it times the last number. Positive 2 times negative 3 is negative 6. So now the number is gone from the front, and it's multiplied into the last number. And so this is called sliding divide. We're sliding the 2 over to the end by multiplication. It's gone from here, it's absorbed into here. And now we are going to go ahead and factor this like we know to do. The leading coefficient is 1, so we can use our simple technique that we couldn't use for this one. Negative times a negative is a positive. We're looking for 2 numbers that multiply to 6 and subtract to 5. So let's do all the factor pairs that would multiply to 6. 1 times 6 would do it. 2 times 3 would do it. That's all we're going to get. Is there something here that subtracts to 5? Well, this does it. So our 2 numbers that go here are 1 and 6. We always write the bigger one first, smaller one second. And so now we have taken our strange, new, different quadratic and we have factored it. But remember, this is not this. So how are we going to compensate to make this come out to where it should have? Well, we multiplied by 2, so we are going to divide by 2 here and here. Whatever number's in front and you multiplied by the last number, you are going to divide this number and this number by that same number. Okay, now x minus, we have 6 divided by 2, that reduces to 3 over 1. First thing you do is reduce your fractions. After you make these fractions, you're going to reduce them. 6 divided by 2 is 3. This reduced into an integer. This one, however, is not going to do that. Okay, this is 1/2. It's as reduced as it can be, but it's not going to turn into an integer. If it doesn't turn into an integer, this is what you're going to do. This is one of the big takeaways of this technique. If it remains a fraction, you are going to take the bottom number and move it up in front of the x. And so that's going to give us 2x plus 1. And that's what there is to this technique. This is now the answer to the factorization of this. If you FOIL this, you will get this back. And so that's what this is all about. To sum up real quick, if your leading coefficient is not 1, then we find a way to create something that does have a leading coefficient of 1. We multiply this number by the last number, and then we're going to divide by that same number here and here. And that will make this come out to where it should have been if we had done a different factoring technique that would have been a lot harder, but we wouldn't have altered it then. So this little alteration we do here is kind of like breaking the rules, but then we make everything right by putting it back. There are other ways to factor this without doing this, but they are harder. This is the simplest way that I think there is to go. Okay, on this example, let's check and see, is there a common factor to all three terms here? By the way, remember what a term is. Terms are things separated by plus and minus. So we have a term here, there's a plus, another term here, here's a minus, here's another number or expression, whatever it might be, but we have three terms here. Is there some factor common to all three terms? Well, no, there's not. So we are not going to get rid of this 9 and turn this into a leading coefficient of 1. But wait, we actually are, because like with the last problem, we're going to do a little maneuver and break the rules. We're going to take this 9 off of here and we're going to multiply it by this number. And so we're going to get x squared. Remember, the middle term stays the same as it is. And then we're just doing positive 9 times negative 8. That's going to be negative 72. So again, this has turned into something completely different from this, which is not all right. But we are going to make it all right in a little bit. So here we can go ahead and do our technique. This sign comes straight down. Positive times a negative is a negative. And we are looking for two numbers that multiply to 72 and subtract to 6. So let's find all the factor pairs that multiply to 72, and then let's see if there's something in there that subtracts to 6. So 172. Does 2 work? Yes, 2 times 36. Again, remember, this is where you can just take a calculator and just go right up the line. Do 72 divided by 2, see if you get an integer. Well, yeah, this is an integer. Take 72 divided by 3, and we also get an integer. 72 divided by 4, we also get an integer. 72 divided by 5 would give you a decimal, so 72 isn't evenly divisible by 5, so that doesn't work. Does 6 work? Yeah, 6 times 12. Does 7 work? No, that would give you a decimal. Does 8 work? Yes, it does. Now, if I keep going, then you'll see I'm using the numbers here that I already used. I'm not going to say, well, does 9 work? Because if it, that's just going to give me this back. So once they sort of meet in the middle, you're just duplicating yourself, so you know your factor list is done. Do we have something in here that subtracts to 6? And yes, we do. So we write the bigger one first, smaller one second. Okay, now we did the slide. We slid 9 over by multiplication. Now we're going to take that same 9 and we're going to divide both of these by it. Okay, so remember, next step is to reduce your fractions. 12 over 9, I'm not going to go into how to reduce fractions here, but if you reduce 12 over 9, it turns into 4 over 3. And if you reduce 6/9, that turns into 2/3. If these turn into an integer, they're done. But if they turn into a fraction that is not reducible into an integer, that is where, remember, we're going to take that bottom number, and it's going to go up in front of the variable. And so that's going to give us 3x plus 4 and 3x minus 2, and we are done. The factorization of this is 3x plus 4 and 3x minus 2. Let's do another one. So we have a leading coefficient of 2, and none of the three terms have a common factor that we can pull out. So we're going to have to do our slide divide technique. And so when we do that, we're going to have x squared plus 13x, and then 2 times 15 is 30. So I'm going to speed up a little bit now. This sign comes straight down. A positive times a positive is a positive. And we're looking for numbers that multiply to 30 and add to 13. So 1, 30. Does 2 work? Yeah, 15, 3, 10. Does 4 work? That would give you a decimal. Does 5 work? Yes, it does. And after this, we're duplicating ourselves. So is there something here that adds to 13? Well, yes, there is. So, okay. We multiplied by 2, so now we need to divide by 2. So here we're going to get, so 10 over 2 reduces to 5 over 1, which is just 5, which makes sense. 10 divided by 2 is 5. This is an irreducible fraction, so the 2 is going to go in front of the x, and we leave the 3 over there, and we are done. Okay, so on this one, looks like we have a common factor to all three terms because they all divide by 5. So first thing we're going to do is take out a 5. What about the variable? We have an x cubed, an x squared, and an x. What would be the common factor between x times x times x and x times x and just x? Well, obviously we could pull an x out of all of those. So you always take out the smallest power of whatever the variable is if there is a variable in every one of the terms. Okay, so now we want 5x times something here to equal this. So let's take 30x cubed. Actually, let's do it like this. Okay, that's x cubed, x times x times x. And we're dividing that by 5x. So that's going to give us 30 divided by 5 is 6. One of these cancels. That leaves us x squared. And so this is going to be x squared. Okay, then we're going to do negative 55x squared divided by 5x. Actually, again, let's do this. I want this to be as understandable as possible, and it's easy to see the cancellations when you do this. So that's going to give us a negative divided by a positive, 55 divided by 5, and then this turned into a 1, and that just leaves an x, so we have negative 11x, and then 20x divided by 5x. Okay, well that cancels, and 20 divided by 5 is 4. Okay, so we made this smaller, but we still didn't get rid of the leading coefficient other than 1 because we still have a 6 in here. We're not going to be able to get rid of that. So let's take this off, down below here, and let's work on it. Okay, well, we're going to do our maneuver. 6 times 4 is 24. Okay, So I'm looking for two numbers that multiply to 24 and add to 11. So does 2 work? Yes. Does 3 work? Yes. Does 4 work? Yes. Does 5 work? No. And then if we try to say 6 again, well, we're duplicating ourselves. So this is the complete list. Is there something in here that adds up to 11? Well, there they are. So we're going to take these, and so this is going to be negative. A negative times a positive is a negative, so these are both going to be negative. Then we take our bigger number, write it first, smaller one second. Okay. Now this is where we have to remember we multiplied by 6 to get this. Now we have to divide by 6. And next step is to reduce our fractions. I'm running out of space, so let's come down here. 8 over 6 is the same as 4 over 3. And then here we have x minus 3 over 6 is 1/2. And neither of these turn into an integer, so on both of these we are going to take that bottom number and shove up in front of the x. Okay, so this is the factorization of this, which is this. So we have our answer. So remember, this 5x is still here. It still needs to be here. This we factored into this. And this is our factorization of this. This is equal to this. On this last example, you're going to notice that we have two variables here. We have an x squared and an x like we're used to, but then we also have a y and a y squared. And I have a pretty simple technique that I haven't seen another teacher teach. Maybe they do, but it seems pretty easy. And so that's what I'm going to do. What we're going to do is we're going to simply rewrite this with no y's in it. Okay, so this is just like this, except I've removed all the y's because it's really easy to put them back later on. Okay, so now let's just go ahead and factor this. Is there a common factor to all three terms here? Well, no, there's not, which means we're going to go straight to our little maneuver. We're going to rewrite this with the 2 times the 15 on the end. So we're going to have to remember to come back and divide by 2 in a little bit. Okay, well, let's go ahead and do this. So bring that sign straight down, and a positive times a positive is a positive, and we're looking for two numbers that multiply to 30 and add to 13. So 2 works, 3 works, 4 doesn't work, 5 works. Is there something here that adds to 13? Well, there we go. So 10 and 3. And now, since we multiplied the 2 over, we need to divide both of these things by 2. So we're going to get x plus 10 divided by 2 is 5. Here, the 3/2 is not going to reduce into an integer, so that 2 needs to come up in front of the x. Okay, and so we have now factored this. Okay, We're almost there, but remember, we took those y's out. We're going to have to put them back in. That's pretty easy. So let's just take this, which is almost the factorization of this. And notice I left a little space here on the end, because all we're going to do is stick a y in the end of each of these parentheses, and we're done. That's all there is to it. If you FOIL this out, you will get this back. There's a way to do it leaving the y's in, but it's so much more thinking. To me, it's not worth it. So I think it's just a lot easier. I think it's worth it to do like we did here. Okay, so that's all I'm going to do in this video. I recommend that you go through all the problems that we did, take each individual one and try to do it yourself without looking. That's the best way to learn math, is take something you just saw and try to do it yourself without looking. And I think you'll find that pretty quickly you start getting pretty comfortable with this technique. Hope this helps.